Okay, let's start Dot1x Authentication. If you have still doubt how it works and what is Dot1x Authentication, please subscribe my channel. I don't want to waste your time. Let's start explanation of Dot1x Authentication. So as we know, in the Dot1x Authentication framework or the EAPoL framework, we need three major components, which is one is the client, one is your authenticator, and the third component would be your AAA server. So in this example, so Microsoft Windows is Supplicant, Cisco switch as a vendor I'm taking here, AAA server is my Cisco ISC, and then we have a database server which is Active Directory I'm using for user groups. All right, so before you start Dot1x Authentication, so as I have already explained in my previous videos why we need this. It's nothing but to control your network access, whether it is wired, wireless, or VPN. All right. So when you already have enabled Dot1x feature on the supplicant and on your switches, so let me just use my pointers. So if you have already enabled Dot1x authentication on client switches, obviously we need to create some policies and on AAA server. So when the first time clients try to authenticate on the wired or wireless network, what happens? The EAPoL-start message will go to the switch, and on this particular point, because we have a Dot1x authentication enable on my SSID if it is a wireless, or the Dot1x authentication on the wired interface, switch interface. So it will stop that particular traffic and send back a request identity message to the client. So client will send back a user ID in this particular EAPoL response, and then when it is received by switch will re-encapsulate that packet into the radius. If the slide does not look very clear, but let me just tell you from this particular point to this point, switch to AAA server radius protocol is working, and from client to switch EAP over LAN protocol is working. So this is the combination of two protocol, which we call it either Dot1x authentication or EAP framework. So here the first packet was received by ICE server, AAA server, and when it sees the access request is coming from this particular user, so it will again send the challenge, because here first packet is received for access the network. So iServer will do first negotiation with the client before further doing any actions. It will first send, because I'm taking here an example of PEAP, and MSCHAP. Okay, so in PEAP MSCHAP we do protocol. What happens? Only server side certificate is required. You don't need a client side certificate, but yes, we need the root certificate on both sides, so that they can identify that both are legitimate or belongs from same domains. Okay, so they should trust some CS server, that is the root certificate, which is the local certificate of this CS server has been installed on Cisco ISE and the client side. They should trust that CS server at least. Based on that, they will negotiate the tunnel in further conversations. So after that, first packet is received by Cisco ISE, then the challenge will be sent to the switch. Along with that, it will also send which protocol do you want to use. Here in, if you see the EAP request, this is a request message going back to the client. Okay, yeah, this way, directly going to the, so basically here on this particular point, the switch, which is authenticator, this will encapsulation here, encapsulation and decapsulation will happen. Okay, so EAPoL LAN packet will be encapsulated in the radius, and when ICE will respond back, the radius will be de-encapsulated. It will de-encapsulate the radius packet and send back into the EAPoL line format. All right. So this stage, on this stage, the negotiation of the protocol and the TLS tunnel establishment will happen. All right. So PEAP also establish TLS tunnel. Okay. And then in this TLS tunnel, MS SHAP will be used to share the credential, transfer the credential password from client to the AAA server in this tunnel. Once it is, if you are able to imagine this packet flow from start to till here, so this is still authentication process is happening. Now you have received the credential. Cisco ISA will go to the Active Directory and validate against these users in the group, because it has all the groups permissions that Cisco ISA can read when we do the integration by using the admin credential. So it will search from which user this access is coming. This user belongs in which group, so that it can apply the appropriate policy based on the authorization profile which we have created on the Cisco ISC. All right. So user founds in group, and as we know in profile, authorization profile, oh sorry, policy, in authorization policy, we have a conditions. If external group, because we have Active Directory and external group belongs to IT user group, for example, then as a permit, which what we are giving here, so ACL 10, and oh sorry, the dynamic VLAN we can say 10, and the ACL what we are creating is as a DACL, dynamic ACL and the dynamic VLAN both we can say here, because per user group you can assign different ACLs and different VLANs. This is how you are managing the access control for different type of users, what they need. For example, we have um, this group, there are four different groups, so all the groups can be assigned in different VLANs, okay, based on their privileges, privilege access, and the access is defined. This way we are controlling role-based access as well. So the last packet, when it has been validated by the Cisco ISA as well, then access accept message will go to the authenticator mediator, okay, and then at this particular point the port will open to transfer further packets, like Dora process will start here. Only then the user will get the IP address, and then it can send the HTTP or any DNS traffic further, for the communication to the websites or any internal network. After the authentication, each success packet will receive by this authenticator, it will again start request for the accounting, because you know the steps: initiation, authentication, authorization, and then accounting will start. So this is how the Dot1x authentication process work. But in between we have encryption generation will also happen between uh, supplicant and to the authentication server, because it will be sent by the AAA server to the switch, and then further negotiation will happen between the supplicant and the switch or the WLC or the access point. So this keys generation is nothing but when the Dot1x authentication is successful. After that, the key will be generated so that further traffic will be encrypted. The data traffic will be encrypted by using those shared keys. So shared key is a separate topic that I will cover in a separate video. Thank you so much for watching. Please subscribe my channel. Thank you.